Hi, hello. Today we shall be developing panel data. We have three models such as pooled OLS model and number two fixed affect or LSDV model and random affect model. And here we have taken four countries. Here we have taken four countries such as 1, 2, 3, 4. And we have three variables such as GDP, consumption and export. And here we want to check the relationship between GDP and other two variables such as consumption and export. And here our data is from 2000 to 2010. So our observation would be 44 in total. Okay, our first model, pooled OLS model. Okay, here we pool all 44 data together and run the OLS regression model. Sorry, neglecting, just 1 minute, neglecting the cross section and time series nature of data. And here the major problem with this model is that it does not distinguish between the various countries that we have. In other words, by combining the four countries by pooling, we deny the heterogeneity or individuality that may exist among four countries, within four countries. That means here we assume that all countries are same, and normally they are not same normally, right? But they can be same, but normally they are not same. Okay, then the second model is fixed affect model. The fixed affect model allows for heterogeneity or individuality among four countries by allowing to have its own intercept value. And here the term fixed affect is due to the fact that although the intercept may differ across countries, but intercept does not vary over time. That is, it is time invariant. And what about random affect model? Here our four countries have a common mean value for the intercept. And finally, I shall apply the Hausman test to check which model such as fixed affect or random affect is suitable to accept. Okay, first I talk about Hausman test. Here the null hypothesis is random affect model is the most appropriate, and alternative hypothesis is fixed affect model is appropriate. And here if if here here if I get a statistically significant p-value, I shall use fixed affect model, otherwise random affect model. And then finally I shall be doing the diagnostic checking. Number one, I shall check whether there is serial correlation in the residual. Here I shall use the Pesaran CD test to test whether the residuals are correlated across entities. And here the null hypothesis is there is no serial correlation, and alternative hypothesis is there is serial correlation. And also I shall develop also I shall appoint modified wall test for testing heteroscedasticity. And here the null hypothesis is residuals are homoscedastic, and alternative hypothesis the residuals are heteroscedastic. And here actually our data that we have, and here I say the first variable is consumption, second one is export, third one is GDP, and it is the country, and it is the year. And here we have four countries. You can see country 1, then country 2, you can see, and here is country 3, and here is country 4, right? You can see until here, and the year is from 2000 until 2010 for each four countries, right? You can see 2000 until 2010 for each four countries. Okay. Now, I shall run our model. So what I'll do? Okay. So first I run pooled OLS model, right? First I run pooled OLS model. Okay. Then how to run? I go to statistics. Then I go to the linear model. It is here, right? And here all the countries are same, that I assume. So the dependent variable is GDP, and here is the export and the consumption are the independent variables. So I run the model. So this is my model, you can see from here. Okay, this is model. I make it big slightly. The font size I make it 14, right? Okay, so this is the 14 font size. So this one is the pooled model, right? Pooled OLS model. Okay, now actually, and here I assume that all the country are same. Okay, but mainly I shall develop two model. That is our target. I shall develop fixed effect model, and I shall develop random effect model. Okay, so first I develop the fixed effect model, right? That I develop first. So I go to statistics. I go to the longitudinal panel data, right? And then I go to the setup. Then I declare data set. I select this one. Okay, then here I put panel data, and panel ID is the countries, right? And I put the time variable, that is our year. All the year we have, year from 2000 until 2010, right? Then I press OK, right? I press OK. Okay, so you see the year from 2000 until 2010, and it is balanced data, right? Balanced data. Okay, now first I estimate the fixed effect model. Okay, I go to statistics as before, then I go to longitudinal or panel data. then I go to linear models, then I go to linear FE, right? Fixed effect model. So I select this one. Then here is the dependent variable. I put the GDP as the dependent variable, and consumption and export are the independent variable. And here I select the fixed effect, right? Here I select the fixed effect and I press OK. So here you can see the fixed effect model. It is the fixed effect model. I can see from here, right? And what I do, I I uh, I I store the fixed effect in fixed effect estimate in the memory, right? That I do, right? Fixed effect I, not one, I, right? I. Okay, I stored the fixed effect estimate in the memory. Okay, I go to statistics, then I go to post estimation, then manage estimation, then store in memory, that I select stored in memory. I select it. Okay, then here I write fixed, right? Fixed. That the store name is fixed, right? Then I press OK. So you can see that it has been stored. Okay, now I estimate random effect model, right? I estimate random effect, right? Okay, so I go to statistics, then I go to the longitudinal map model, then linear models, then I select the random effect model, RE, right, that I select. And here the GDP is the dependent variable and consumption export are the independent variable. And here I select this one, GLS random effect model. I select this one, then I press OK. So this is my model. You can see random effect model, right? This is my model, random effect. You can see from here. Okay, now what I do, I also, as before, I store the estimate in memory as before, right? Okay, I go to statistics, then I go to post estimation, then I go to post estimation, then manage estimation result, then store in memory as before, stored in memory. I do all these things. Okay, so this time the name I put as a random. I put as a random because this one is the random effect model, and you can see. So uh, the it has been already stored. Okay, now I shall appoint Hausman test to check to check which model is appropriate, right? Fixed effect, or random effect, fixed effect or random effect, which model is the most appropriate, right? Okay, so Hausman test can can tell me which model is the most appropriate. Okay, so I go to statistics to check it, then I go to post estimation, then I go to test, then I go to Hausman test. It is here, right? So I selected Hausman test, I select it, and from here I select the fixed, right? I select the fixed, and then I press OK. I press OK here. I press OK. So actually he so here is the uh, outcome of the Hausman test, right? So here you can see. So here is the probability. This is the chi-square value and the corresponding probability. And here is the null hypothesis is for this test is the null is that null is for this model random effect model is appropriate. That is the null. And alternative hypothesis is uh, fixed effect model is appropriate. Fixed effect model is appropriate. Okay. And here what is happening? The probability value is less than 5%, right? Meaning that we can reject the null hypothesis and can accept the alternative hypothesis, meaning that fixed effect model is the right model, and fixed effect model we should accept as our model. Okay, now I estimate the fixed effect model now again, right? Again, okay. I go to statistics, then I go to the panel data, and then I come here, then I come here. That means fixed effect model, right? It is FE, it is here. I select this one, I select this one. Okay, then here I select the fixed effect, right? I select this one, and then I press OK. I press OK. So here you can see the fixed effect model that we have, and here is the GDP is the dependent variable. Export and consumption are the independent variable. Okay, but here the problem is that what about this variable consumption? The probability value is 74.3%, meaning that this that means 74.3% means more than 5%, meaning that this variable consumption is not a significant variable to explain the GDP. Okay, then what about the second variable, export? The probability value is 47.9%, meaning that export also is not a significant variable to explain the GDP. So meaning that consumption and export both are not significant. So we are not happy about this model, right? Because the model actually not very good, right? And also here you can see F statistics, and the probability is 77.3%, which is more than 5%. That means F statistics is not also significant. So that is not also good, right? That is not also good. So this model actually not good because no variable are significant to explain GDP, and also F statistics is not significant, so this model is not good. And okay, now we check whether this model has serial correlation or not. So for serial correlation, I can appoint Pesaran CD test, right. So Pesaran CD test I can appoint, okay, to check whether our model has serial correlation or not. Okay, and here the 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 uh, command would be actually xt xtcsd, right. So that would that is the command. So I put it, then I press enter. Sorry, I think here I have done a mistake. The command is not right. I put xtcsd. Okay, I put it. No, sorry, xtcsd. Then I write pesaran, and then I write cd. Sorry, not cd. I write abs. So that is my actually command to estimate serial correlation in this model. CT, CTCSD, Pesaran, ABS. Okay, then I press enter. I'm sorry, here I've done mistake. Again, I'm doing I try again. XTCSD, comma, Pesaran, comma, ABS, right? Then I press enter. No, I think I'm doing mistake somewhere. I try again. Okay, so the I write it XTCSD, then comma, then I write Pesaran, then I write ABS, right? So here you can see, right? XTCSD, comma, Pesaran, ABS, and I enter. You can see, so Pesaran test for cross-sectional independence. So here the probability value is this one, you can see, and our null hypothesis is there is no serial correlation in the fixed effect model that we have chosen, right? And what is alternative? There is serial correlation, right? There is serial correlation, right? And here the probability value is how much? You can see probability value is 3.69%. 3.69%, which is less than 5%, meaning that I can reject the null hypothesis and I can accept the alternative hypothesis, meaning that there is serial correlation, and that is not desirable. So this model actually not good because there is serial correlation. Okay, finally I check whether our model has heteroscedasticity or not, right? And here actually we shall use modified wall test to check whether there is heteroscedasticity or not, right? Okay. And here the command is xttest3. That should be the command. Okay. So what I do, take the command here. Right? xttest3, right? That is the command. Then I press enter. Okay, here is the thing, the chi-square value and the probability. What is the null hypothesis? Null is residuals. That means residuals are homoscedastic. And what is alternative? Residuals are heteroscedastic, right? And here the probability is how much? Yeah, you can see the value of chi-square and the probability. You can see the modified wall test, right, for heteroscedasticity in fixed effect model, right? So here is the chi-square value and corresponding probability. Probability is less than 5%, meaning that we can reject the null hypothesis and can accept the alternative hypothesis, meaning that there is heteroscedasticity in the residual, and that is not desirable. So our model has actually so many problems. Number one problem that I am saying, that F statistics is not significant. Number two problem, our two variables such as consumption and export are not significant, and also here our model has serial correlation, and also the residuals are heteroscedastic, and that is not desirable. So we cannot accept this fixed effect model so far. Thank you very much for being with me for a while.